Hey everyone, welcome back. So today we are going to see second part of descriptive statistics, different measures of dispersion and which one to use and when. So you have already seen this diagram in my previous video about different measures of central tendency. So today we are going to cover the mid section, the highlighted one about the dispersion and the variability of the data. So what is dispersion? So spread or scatter of your data, and it shows extent to which given data is stretched or squeezed. And you can say it tells us about the variability of data, how much squeezed or scattered your variable is, or how much data is spread around a central value or the mean value of your data set. So there are different measures of dispersion. So let's see one by one. So first is range. So how do you define range of a data set? So it's max value minus min value. Therefore, it's considered as the simplest measure of dispersion. So for given values, range would be 7 minus 1, 6. Now it's sensitive to outliers. So here you can see 98, it's quite higher than the other remaining values. So it's an outlier, and range, it's 97, quite a higher range. So yeah, keep it in mind. Then third, it can be used for small size data, yes, and it ignores the way data is distributed. So whether data is skewed, positively skewed or negatively skewed, it doesn't take into account. So next is IQR, interquartile range. So first let's see the formula. So it's Q3 minus Q1. So upper quartile of data minus lower quartile of data. It gives IQR of your data set. So to understand this, if you have used, if you are aware of box or whisker plot, you might be knowing 5-number summary, which is used to show the distribution of data in box plot. So there we divide the data into sections that each section contain approximately 25% of the data. So like this, we have a data values. So the 5-number summary, what I mean is minimum of data. Then we have Q1 first quartile, that is lower quartile. Then the median, which is second quartile, is Q2. Then Q3 is the third quartile or the higher quartile. And finally, the maximum value of the data. So yeah, the mid spread of the data, the mid 50%, yeah, this mid 50% is it gives us interquartile range. So mid 50%, what I mean is Q3 minus Q1. So the third quartile minus first quartile, or you can say higher quartile minus lower quartile, it gives us interquartile range of a given data set. See the steps to compute IQR. So for example, let's take a set of values. So first step is to sort the data. So now we have sorted values. Then next step is to find the median. So for these values, we have 8 as a median, which is the second quartile. Yeah, the median is the mid quartile of the second quartile. So it's Q2. So next is find the median in lower and the upper half of the values. So median in lower half will be a Q1, the first quartile. So here 4. If you see lower quartile, 4 is the median, and in the upper half we have 10 as a median. So Q3, that will be upper quartile. And the final step is to calculate interquartile range, which is Q3 minus Q1. So upper quartile minus lower quartile. So here we'll have Q3 minus Q1, 10 minus 4, 6. So 6 is the interquartile range for this given set of values. So going ahead, IQR is robust to outliers, so that is a very good thing. So whenever you see your data set is having extreme values, then go for IQR as a measure of dispersion. Because because I said previously, mid spread of mid 50% of the data, that's the IQR, because it doesn't consider the lower extreme values or the upper extreme values. So it's obvious that it's robust to outliers. So yeah, the conclusion is if data is if data has outliers or if it's skewed data, use IQR as a measure of dispersion. Otherwise, you can go with variance or standard deviation. Next measure is variance. We all know it's average of square differences from the mean, and we are quite familiar with the formula also, both for the sample variance and the population variance. And in denominator, the n minus 1 or the n differences is due to Bessel's correction. We can cover in another video, or if you want, you can look into. So again, yeah, it's not good for skewed data and also susceptible to outliers like mean, because yeah, it's considered, all the values in your data set. So larger the variance, further the individual cases are from the mean. So smaller the variance, closer they are to the mean. You can see the graph. So now the steps computing variance, and as an example we are given with different heights of puppies, and the first step is to find the mean, and here the green line depict the same. So the second step is to calculate difference of each dog's height from the mean, and finally square each differences and then average it, and it gives us variance. So remember that we are squaring each differences in the final step, and because of that, the unit of variance is square. And because of this reason, standard deviation comes into picture, because the unit of measurement of original data, if you see, it is in and the variance we have obtained is in square. So variance is no longer in the same unit as original data because of squaring the differences. And to help with this, we come up with a solution which is square root of variance, which gives us standard deviation. The final measure is standard deviation. We all know the formula, and is the most common, stable and widely used measure. And just like mean and variance, it's not good if your data is skewed or if your data has extreme values. So lower standard deviation, what does it mean? So data are less spread out and are clustered around mean, and higher standard deviation means data are more spread out. So here you can see different distribution shapes in context of mean and standard deviation. So going forward, when to use standard deviation? Yeah, obviously if your data has less outlier, or if your data is not skewed. Otherwise you can go for interquartile range. I have already explained before. So here is a question: what's good to have your data with high standard deviation or variance, or low? So I leave this question up to you. So now the summary. So yeah, you can briefly go to the summary, and I think that's all in this session, and see you soon. Thank you.